I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 24th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we see the beginnings of a gale in the North Gulf of Alaska producing 22-foot seas. This is the first in a series of gales that are going to push down through this region towards the U.S. West Coast. We also see the beginnings of a development of a gale off of Japan. Not a whole lot expected from this initially, but it might blow up as it hits the North Dateline region later in the week. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales when they do form, help direct their track. We're looking for a trough that is a dip in the jet, just like right here. What that helps do is create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And low pressure, if it's strong enough, generates winds. Winds, if they're strong enough and over a large enough fetch area, generate seas. Seas, if they're large enough, turn into swell as they radiate away from the fetch area, and swell, of course, when it hits your beach, turns into surf. So, troughs are an important part of the swell production machine. Alright, so we have a little bit of a trough here over the North Dateline region, nothing too impressive. What is of more interest is the jet isn't even consolidated pushing off of Japan. If you recall, a couple weeks ago, the jet was a full raging river of winds at 200 knots tracking from Japan the whole way to the U.S. West Coast. Here we are 2 weeks later. The jet is weak, barely holding together, making it to the dateline, then splitting heavily with the northern branch, traveling up into the northern Gulf, then falling down the U.S. West Coast, and the southern branch pushing south, even west of Hawaii, towards the equator. Typically what you get in between the split flow is high pressure right there. And that is the hallmark of what's going to be happening for the next several weeks. But the one good thing from this is, yes, it's not great for storm production, but what it does is it pushes the jet to the north. And then if this high is displaced close enough to the dateline, it allows the jet to fall southeast off the U.S. West Coast and into California, providing much needed moisture and snow in higher elevations. So all hope is not lost. All right, so let's put this into motion. We can just see exactly what's happening. The jet continues on Monday, split off of Japan. Here comes, it's actually kind of a trough trying to push into California, but not enough to really be meaningful. Another more interesting trough starts developing off of British Columbia on Tuesday. Also notice a trough winding up off of Kamchatka. This will support some modicum of storm development there. This trough lifts off to the northeast as we get into Wednesday, while the other trough, look at that, builds off of California, setting up the jet pushing right into the North California coast. When they talk about atmospheric rivers, what they're really saying is the jet stream flowing directly over the coast. What that does is pushes a lot of wind energy and moisture just north of the jet and right where the jet is into the coast, and that's what makes for some significant rainfall events. Now notice this one pretty much holds just focused right on the Bay Area up into the Tahoe region, and we'll call this the Central and Northern Sierras as we get into Thursday. And then Friday it pulses again. You get the idea here. And then what happens? It starts falling south into Southern California, but then as we get into Saturday, another trough starts building off to the north, possibly setting up the exact same scenario beyond that. And at the same time, another trough starts building off Kamchatka with 190 knot winds, offering support for gale development there. So high pressure and a giant massive ridge in the middle of the Pacific, but with a trough on the far west side, trough on the far east side. That's where all the activity is. Not great for storm production, but these systems that do form off of Kamchatka, they can push energy to Hawaii because Hawaii is closer, and the U.S. West Coast, but a long ways away for California. And with all the weather going on locally, doubtful the swell will even be noticeable, even in Southern California. pretty much massive amounts of wind swell and locally generated swell will be the name of the game. Let's go take a look down at the ocean surface, and you can see the picture pretty well here. High pressure, 1040 millibar, bulletproof high pressure, right centered smack in the middle of the Gulf of Alaska. 30-knot winds driving down the coast. That is as of Sunday. A low-pressure system here off of Kamchatka. That one's not so much of interest. It's this one off of Japan that's supposed to blow up as it starts tapping jet stream energy. And you'll see this as we get into Monday. 55-knot winds, but all aimed due south, not at Hawaii. Probably nothing associated with that. But also notice this high pressure generating strong easterly fetch, trade strong into Hawaii at 20 knots. We move this forward just a little bit. Then a system, the first in the series, develops in the northern Gulf Monday night, 50-knot winds, while the system off of the Kuril Islands or Japan starts building with 45-knot winds, aimed better at Hawaii, but also lifting north incredibly fast. In fact, 12 hours later, it's over the North Dateline region with 45 to 50-knot winds. The other system here off of Vancouver Island with 45-knot northeast winds in close proximity to the coast, high pressure locked in between. As we get into later on Tuesday, 55-knot winds over the North Dateline region, 40-knot winds off of, we'll call it the Pacific Northwest, but it's almost blowing directly into California. You get the idea. Surf generation here, but also lots of weather, 30-knot winds pushing into the coast. Let's get into Wednesday. Same deal. North Dateline region system starts fading with 45-knot winds. The system off of California starts fading out as well. And then we have another developing system off of Japan as we get into Friday. Another system in the Gulf also with 30 to 35-knot winds. We'll just roll this out a little bit into Saturday. Where are we here? There we go. Again, 30, 35-knot winds as we get into Saturday morning, aimed at California. Broad low-pressure system off of Japan, and lifting again to the north as we get the last frame of the image. Still, pretty much the same picture. Storm here, high pressure, strong trades driven by the high pressure, pushing into Hawaii. Steady state, the exact opposite of what we had 2 weeks ago. This is more of a kind of a classic La Nina sort of pattern. But you know what? The rain in this direction is a good thing. We'll take it. All right, going back in time just a little bit. We're Tuesday this past week. So what's that about? Maybe 5 days ago. A system built off of Japan. Pretty solid, actually, with 48-foot seas right there. You can see it right there. 48.9 feet. And building as we got into Wednesday. Peaked out, right back here, I think. 52-foot seas approaching the date line. And then it faded and lifted off to the northeast. The point being, swell from this system has already, for the most part, passed Hawaii. There was some swell there today, still from this, pretty solid, but nothing huge. And the first long period forerunners of this swell is hitting Northern California this evening. Nothing huge, like 4.5 feet at 20 seconds, pure swell. Anyway, that system faded. We go into Saturday. And really, there was not a whole lot of activity. The beginnings of the first in the series of gales started in the northern Gulf of Alaska. Let's go take a look at the forecast now. We know where the storm pattern is, here and here. Let's put it in motion and see. And we're kind of watching this system off Japan here because it is an interesting one. It builds, tries to get traction here, aimed really well at Hawaii. Well, at least in a good position for Hawaii, but all the fetch was aimed to the south. But then it quickly gets sucked by the jet stream to the north and builds rapidly on Tuesday, while the system in the Gulf also starts building with 34, 35-foot seas, something like that, falling southeast rapidly. This one building with 56-foot seas aimed off to the east. Now you notice Hawaii is down here. There is a great circle track that goes something like that, but most of this energy is aimed pretty much well east of those great circle tracks. The track into California goes more like that, but California will be swamped with local wind swell whenever this swell arrives, so probably not of any interest. And you see the local pattern here off of California. Lots of seas, very close to the coast. When you have any kind of magnitude of seas within even 800 miles of the coast, The short period elements of the swell and the long period elements of the swell don't have time to sort out. It just turns into a jumbled mess. More like you want 1,000 miles, 1,200 nautical miles out minimum, something like that for the swell to start sorting itself out. Anyway, you get the idea. Where are we? We're into Friday. Then another system organizing in the Gulf into Saturday, falling south, and another system building off Japan. And you get not as strong as the last pattern, but still pretty solid indeed. So swell for Hawaii, swell for the U.S. West Coast. But again, the local swell relative to California, pretty much overrunning everything. Also notice the initialized date. Oh, this is 18Z Sunday the 24th. It did update. Okay, so the one little bit, we've got some emails, people come noticing that the models haven't updated. Oh yeah, this is the wave model, so of course it did update, but the weather models, and you'll see it. In fact, let's go there real quick. Here we are, local winds relative to California, Hawaii. Initialized 18Z on the 23rd of January. That was yesterday. There has been we get all our data from NOAA for the weather models, just right from their supercomputer. But they had a maintenance window, or they had some maintenance going on at their data center. Something happened, and what was supposed to be a 6-hour maintenance outage turned into 48 hours, and they got one batch of data out the door, and then everything shut down again. We've talked to the NOAA folks. We are presuming that come Monday, when the crew gets back in, they'll get this up and working, and we'll be back in business. So please be patient, and we apologize for the outage. All right, anyway, so we get into Monday. You see high pressure was at about 1038 millibars right there, driving trades, clockwise circulation around it. Low pressure inland, 30 knot. Northwest winds down, for the most part, the whole of the California coast into Southern California. 20 knot trades over the Hawaiian Islands. Not particularly a great day. Notice winds to 35 knots in Southern California as we get into Monday sunset time frame. Here comes the next low building Tuesday. Still a wind fest for most of California, except maybe over Cape Mendocino for a short window. Trades nuking for Hawaii. And as we get into Tuesday, here comes the big front, the main front. 30 knots to 35 knots southwest winds up into Cape Mendocino. Trade still 20 knots plus for Hawaii. The front pushing down overnight into the Bay Area. Wednesday morning from the Bay Area down into Big Sur, maybe say Morro Bay. Full-on southwest gale event. Trades continuing for Hawaii. Then mellowing out later Wednesday. Trade still brisk for Hawaii. Thursday, the low associated with, remember, the jets falling down like this, sitting right off of the Central California coast. Still the front just like stalled right somewhere between, we'll say Monterey Bay and Point Conception. Winds blowing hard all day long, trying to make it down into Southern California Thursday night. Get into Friday, little bit of a mellow out thing. Trades mellow slightly for Hawaii as well, but still 20 knots, something like that. Here comes the next system as we push into Saturday. Not as vigorous. You see just 30 knot winds offshore, but near shore, not too bad a situation. 20 knot trades continue for Hawaii, and then we get into Sunday, the model ends, but you can see some variation on the same theme likely setting up with a 1036 millibar bulletproof high pressure system set up in the western Gulf of Alaska. The same pattern continuing. Looking at precipitation for California, here we are. We'll say current time right now, it is raining in Northern California. Light snow falling in the Tahoe region, exactly as what the models say. Snow building overnight, rain continuing light along the California coast the whole way down into Southern California. Much needed rain for sure. As we get into Monday, snow continues for the Sierra. Rain for the most part, maybe not so much in the Bay Area up into Point Arena, something like that. Fading out as we get into Tuesday, a break as the next system starts winding up off the coast. Look at this. This is snow very close to the coast, probably higher elevations of Cape Mendocino on the coast. Could see snow indeed. With that system pushing down by Wednesday morning into all the Sierra. Incredibly heavy precipitation forecast in the along the north coast, but even regular moderate to heavy precipitation down to Point Conception, even into Santa Barbara County. Look at the strong snow, and you'll see when we go look at the snow totals for the entire Sierra during the day. Wednesday, backing off a little bit Wednesday night. Second pulse starts on Thursday, lifting north, but Tahoe's right there, right in the center of all of it. Continues all day Thursday night into Friday, rain along the coast. Continuing as we get into Friday. Finally, maybe Friday night or Saturday, it backs off a little bit, but still snow forecast for Tahoe. And then here comes the next one as we get into Sunday. So wave after wave after wave of precipitation and snow. It's all coming. It's sort of like our surf season. Our whole winter season happened in maybe 4 to 5 week window with a little 1 week gap in the middle. Suspect the same thing is going to happen precipitation wise. It's just going to pound us for a month, and then the high will retrograde maybe further west, or it'll all just break up, and that'll be the end of it. So, the other thing is traveling to the mountains, probably not advised. This is all just incredible amounts of precip in a very short period of time. Whiteout conditions, atmospheric river events. You typically see winds at 150 miles an hour or greater over the peaks of the summits. Just whiteout conditions. Not advisable to travel to higher elevations. Snowfall accumulations. Take this with a grain of salt, but you can see it's off the chart. We'll actually blow it up here. Hopefully we'll get it focused so you can see off the chart, but as you scroll down here, this is the total accumulated snowfall potential for a 10-day period. 336 inches at Squaw Valley. If that's probably not realistic. It assumes 12 inches for every 12 inches of snow for every foot of for every inch of rain. Freezing levels, not an issue. Down at the 4,000 foot level, 3,000 feet in the evenings. Winds, we assume, are out of control pretty much. 100 knot gusts, 80 knot gusts, and probably higher on the actual peaks. Quick look at Kirkwood, off the charts too. Let's scroll down and see what the details tell us. 298 inches, okay. That's pretty copious. And then Mammoth, of course, off the charts as well. 169 inches. All this is relative speaking. This is older model data too from the 21st. Probably by Monday we're hoping we'll have updates and have this working again. But either way, a significant snow event is coming just in the nick of time for the Sierra. Let's take a look long term. What's going on with the Madden-Julian Oscillation and, of course, the El Nino Southern Oscillation, which we know is in a La Nina configuration. As usual, we like to look for the presence of the active phase of the MJO, the Madden-Julian Oscillation. This is that periodic weather oscillation that travels around the planet from west to east on the equator. The active phase, when it's over the Pacific, helps support storm formation, feeds energy to the jet stream, and can reverse the trade winds, creating Kelvin waves, which can be the precursors to El Nino. When in the inactive phase, it creates stronger than normal trade winds over the equatorial Pacific, and generally doesn't support storm formation, does not impart energy to the jet stream. So the jet stream splits exactly like what we're seeing, with the split point being at the date line or even somewhere west of there. Exactly like what's happening now. All right, so we look for the presence of the active phase or inactive phase of the MJ over the Pacific by looking at winds 5 degrees north and south of the equator. This is the East Pacific here, West Pacific here. Here's the equator. The arrow is what we're looking at. Strong trades over the East Pacific, Central Pacific, and over what we call the Kelvin wave generation area, the far West Pacific. And this is the important area because when the active phase of the MJO is over here, it in turn then feeds energy to the jet stream, which feeds the storm track. But it's not the actual winds. These are 5-day actual winds here, 5-day average winds here. It's the anomalies, differences from normal for this time of year. You notice the winds are strong out of the east, but that's normal for this time of year. If anything, they're a little bit weaker than normal. The net effect is it's like light westerly winds in the East Pacific, neutral winds over the Central Pacific, and the winds over the Kelvin wave generation area are, yes, they're out of the east, pretty strong, but much weaker than what they've been for the past month, which is kind of a step in the right direction. Here's the 1 week forecast for the east-west component of the wind only. We don't care about the other directions. Are the winds blowing harder from the east or weaker from the east than normal? Right? So time down this scale. The whole planet on one chart here, the dateline, that's our reference point, the dateline, right in the not quite the middle of the Pacific, we'll call it the Western Pacific, but it's the western edge of the Kelvin wave, eastern edge of the Kelvin wave generation area. Pacific starts about right here, 135 east. Okay, Kelvin wave generation area ends 170 west, right here. Remember, in December and early January, all that surf, well, this purples and blues here are strong easterly anomalies. Now, normally that does the exact opposite, just kills the jet stream. But for whatever reason, it was enhancing the jet stream. We think because the Walker circulation changed due to La Nina, and it's a long story. We won't go into all the details. But you notice, as soon as those winds cut off, the storm machine shut down, and now we're in this, and then the jet stream split, which is exactly what's happening now. So here we are today. The forecast for the next week calls for basically neutral winds, maybe light westerly anomalies, otherwise kind of a maybe building light easterly wind pattern at the end of the 1 week forecast, but a bit of a break from the raging La Nina symptoms or conditions that we've been having. Will it do anything for storm production? Probably not, because the whole atmosphere is predisposed for La Nina now. There's no turning back. This is just backs it off for a little bit. Let's look a little bit further out. 2 week forecast. This is outgoing long wave radiation, OLR. Fancy words for cloud cover. The blues, negative anomalies, mean less than normal clouds. That's typically, means less sunlight reflectivity, meaning more clouds, meaning the active phase of the MJO. And we saw that east winds are supposed to be dying. That's typically what happens when the active phase sets up. According to this, the statistic model, and the Kelvin wave generation area is right in this area, the West Pacific. Oh, there's South America, Central America there, Hawaii right there, New Guinea there, dateline right there, equator right there. 5 different panels, 5 different time periods today, 5 days from now, 10 days from now, 15 days from now. You see pretty much the same thing. More cloud cover than usual over the Kelvin wave generation area per the statistic model, suggesting perhaps the active phase of the MJO trying to make a stand finally. The dynamic model, if we can get it centered here, there we go, just like that, painting pretty much the same picture, but the active phase, in fact, maybe we can do it this way so you can see. There we go. The active phase a little bit more to the west than what the statistic model suggests. This is actually a better picture, suggesting the active phase lingering in the West Pacific. Maybe there's a modicum of hope that there will be some energy transport into the jet from it if the La Nina base state just doesn't completely obliterate whatever the active phase is trying to do. Next up, phase diagrams. This one for the statistic model, this for the dynamic model. What are we looking at? This circle here. Assume that's the North Pole, and you're looking down on the North Pole, okay, and the equator is out here around the edges. The MJO travels from west to east around the equator, from the Indian Ocean to the Maritime Continent, Bali area, over the West Pacific to the East Pacific, under the United States, like across the Gulf of Mexico, across the Atlantic, over North Africa, back to the Indian Ocean. Where the heavy dot is where the active phase is, and the further the dot is away from this circle, the stronger it is. So we have a modest active phase over the West Pacific today. This is the strongest active phase we've seen in months and months and months, because for the most part, the active phase has just been getting crushed by La Nina. But today, it is moderately active, but according to the statistic model, 3 different runs suggest it's to move into, we'll say, the far East Atlantic. Far East Atlantic, One very weak, one saying holding strength. The better picture is from the dynamic model, the GEFS model here, saying, no, the active phase is to hold perfectly stationary at moderate strength for the next 2 weeks over the West Pacific. So we like this picture a lot. This one's okay. This one's better. The upper level model, this is a statistic model. This shows, this is a jet stream level. Areas favorable for precipitation. The greens, favorable for precipitation. Orange is not favorable. Consider this the inactive phase. Consider this the active phase. You can see the active phase pushing its way across the... Oh, and there's South America, Central America. There's the equator right there. New Guinea, Australia, Philippines there. Kelvin wave generation area, right in this area here. This is what we're interested in. And so active phase over the Kelvin wave generation area, that should be helping to stomp on those easterly anomalies. And we saw, in fact, in the model over the next week, weak westerly anomalies are to be developing in this area, possibly imparting some energy to the jet stream. You see slowly the active phase working its way across the Pacific and over Central America and out of the picture somewhere around the 18th of February, while the inactive phase builds once again. Our assumption is at that time easterly anomalies will start building in the Kelvin wave generation area. Will it build as strong as what we saw over Christmas into the first 2 weeks of January? Probably not, but a pretty strong, healthy, inactive phase pushing across the Pacific to the end of the model run, March 5th. At that time, another weak active phase setting up over the Kelvin wave generation area. In normal times, we'd say this is the swell window and this is the swell window. But the way things went this last time, we're almost thinking, well, maybe this is the swell generation window. Probably not, but maybe. Then the 4-week CFS model, all right? Whole planet on one chart again. This is the east-west component of the wind. You see, in fact, we can scroll up here a little bit more. You see that big old, right down, the date line is right there, Kelvin wave generation area. Let's see if we can do this again. Yes, from there, the whole way up the chart to about there. This was that sweet spot from, said even November 14th, through just a couple of days ago when all that storm production happened. Now we zoom in on where we are today, which is right here. There, the solid black contours, the active phase of the MJO. This is a equatorial Rossby wave, but the two are to interact, create some westerly anomalies for a week, maybe two, and then a return of easterly anomalies, but weak easterly anomalies. Also notice this dotted contour. This is the high-pass filter. The dotted line suggests a low-pressure bias over, a high-pressure bias, over the Kelvin wave generation area. That's pretty much typical of La Nina. But notice that high-pressure bias getting progressively weaker. It was 2 contour lines. The second contour line is to die in about 2 or 3 days, down to 1 contour line with a weakening easterly anomaly footprint. This possibly suggests the demise of La Nina. In fact, the solid contour high pressure bias here with 2 contour lines, it too over the Indian Ocean. This is the core of where La Nina is. It's basically low pressure over the Indian Ocean. We normally want to see this over the Pacific, but they flip during La Nina. You get high pressure over the Pacific, low pressure over the Indian Ocean, and that too is to fade by the end of February, suggesting the demise of La Nina. And then finally, the 3-month CFS model. Now this is real interesting, a real marked change here. So past performance is down here, the forecast is up here. Kelvin wave generation area starts right about here, going the whole way up the chart to 170 west, right about here. Date line's right there. You notice the blues are easterly anomalies. Here's that strong easterly anomaly event. And starting today and moving forward, you see really no easterly anomalies forecast until you get into April. And that is, do I believe a model even a week out, much less 2 or 3 months out? Probably not. But it suggests a change in pattern, a definite change in pattern. We overlay the MJO, and supposedly the solid contour here, this is the active phase of the MJO developing today, continuing, pushing through the Kelvin wave generation area into the 5th of March. And then at that time, a inactive phase of the MJO sets up through the end of the model run, which is into the end of April, and easterly anomalies redeveloped. Interesting pattern, not sure what any of this means or if it means anything. Suspect this active phase is not going to do a whole lot for storm production. Maybe a little bit. We'll just have to keep our eyes on it. But even as the inactive phase starts building, you notice the yellows, westerly anomalies continuing in the Kelvin wave generation area, maybe, hopefully, feeding the storm track a little bit. The other thing here, too, is, okay, this is a more sensitive filter, the high-pass filter. 1, 2, 3, 4 contour lines in effect, high pressure just locking down the Pacific. This is probably what matters more. Continuing with the 4th contour line into the end of February, the 3rd contour line fading the end of March. By then you're in spring, and then we're down to 2 remaining contour lines. The low pressure bias that's in the Indian Ocean with 2 peaking out, today basically, holding till about mid-February, and then notice it giving up a lot of space here. And this keeps showing up on the model, comes somewhere around the early March time frame, perhaps suggesting the demise of La Nina in the Pacific Ocean. One can only hope. All right, enough of the MJO. Let's go talk about La Nina and its effect on the ocean. We're not talking at the surface of the ocean, down deep in the ocean. This is the West Pacific here. This is the East Pacific here. This is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. These X's are sensors on the anchor lines of those buoys anchored deep in the ocean. And the sensors collect data at various levels down, what is that, about 25 meters, 50, 75, about every 25 meters down into the ocean, down about 300 meters deep. Okay, and the idea is you take that data, use a model, and you piece together a profile of the ocean temperature profile from west to east across the Pacific. This data at 26 degrees, 28 degrees centigrade. Okay, so what you get the sense of, all your warm water is in the West Pacific, and you have a very shallow layer of warm water here, and that is typical of La Nina. Trades blowing hard, creating lots of upwelling, not a lot of warm water in the East Pacific. It all gets pushed over to the West Pacific. During El Nino, the exact opposite happens. This warm water here starts flowing to the east in the form of like a big pool of warm water. That's called a Kelvin wave, like a ball of warm water. It takes 3 or 4 months to make it the whole way across the Pacific. It erupts off of Ecuador and then starts filling in this area here. If you get successive Kelvin waves driven by the active phase of the MJO. That's why we're so obsessed with the MJO. We're always looking for the active phase, for not only because it imparts energy to the jet stream, it also pushes us towards El Nino and transports warm water from the west to the east. Of course, we don't see any of that today, but what we do see is this. So the 28 degree isotherm here, last week it was about 162 east. It's maybe moved a degree or two to the east. Not really meaningful. The 24 degree isotherm right here, I think last week it was at 140, but you notice it's starting to make a little progress here. There's some warming starting to occur in this area at depth, and that is because we believe trades are fading in this area. They've been just nuking off of Ecuador for months now, since April. We think maybe the first little sign of slackening of those trades is starting to set up. Now, it is not the actual water temperatures, it's anomalies, differences from normal for this time of year. And you see, again, the warmest temperatures at depth, 2 degrees above normal, making it to about 170 west, just about a little over the date line. And it's been locked solid here. There's no warm water movement to the east at all. But we do see is a little building pocket of warm water off of Ecuador starting to show up, where normally, see these cold waters here, minus 3 degrees below normal, they were filling all this area. Now they're kind of getting shunted off. They're in the central Pacific and moving to the west, but trades we believe, are slackening in this region. Here's another model of using the same data. It's not as generous with the warm waters here, but we have some other data here that suggests this might be hyping the effect of the coolness right in this area. But in general, down in here, yeah, that's probably about right. Cold water in control, driven by strong trades. Sea level anomalies, no difference than what we've seen in the past. This is data from Jason 3 satellite data. There is Peru there, Chile down there, Central America. Galapagos are right there. Okay, this is the equator there, dateline right there. You see these blues, a big triangle of blue just like that. All that means is the ocean surface height. If you strip out the waves, wind waves, the tides, the sphere of the ocean, or the ocean, the sphere of the Earth, including the ocean, is a little bit less than normal, 10 centimeters, 15 centimeters below normal. Why is that? Cold water at depth contracts, so when it does, it creates a divot on the ocean surface. We know we have colder water all in here, and we know we've had stronger than normal trades pushing warm water and literally the entire ocean surface off in this direction. See the plus 20, plus 25 centimeter anomalies over here. It's because the ocean is displaced off to the east, and temperatures at depth are warmer than normal, expanding, creating a bump on the ocean surface. That's New Guinea right there, so you get the idea. This is the classic La Nina sort of pattern, a triangle pointing on the equator, pointing to the west. El Nino does the opposite, takes the warm water, starts driving it this way into the Galapagos, into Ecuador, and you get a triangle that goes the same look, but it's all warm water over here. So that's kind of the difference between the two. Upper ocean heat anomaly profile, time sequence. You can see, so this is the West Pacific here. This is the East Pacific here. The greens are cooler than normal temperatures. Reds, warmer than normal. You see back in April, the last of our Kelvin waves, warm water pushing off to the west, faded. Cold water, trades, stronger than normal, blowing here, creating upwelling. A little bit of a break we had in late July. And then, boom, a big bout of easterly anomalies. It just went on. The peak of La Nina, probably around Halloween right there. Coldest temperatures. And now you see it kind of carving out here, mellowing out. Notice the really important here is the buildup of warm temperatures in the West Pacific. At some point, they will get to the point where they cannot be held back no matter how much strong easterly trades you have, and they'll start rushing off to the west. The trades will collapse, and that's how you get into El Nino. We don't expect to see that happening anytime soon. Maybe not for at least another year to year and a half. But the stage is being set, we think, for that eventuality. Next up, sea surface temperature anomalies. Differences from normal for this time of year. Picture, nothing new than what we've seen. The blues colder than normal. And again, now the big triangle like that. But notice right here, there's the Galapagos, and for the first time we're seeing warm anomalies building on the equator the whole way out to 130 west, so that's California ends there, and we're even past the end of California. Not a broad expanse, not markedly warm, but a definite trend in the right direction. Still, much coldness radiating off of Chile and Peru, and the peak of what we call the La Nina cool pool, it's really only 5 degrees north and south of the equator. So what's that, 20 degrees? So it's from there, the whole way across, to right about the top of this line. Well, let's see, there's 0, so 5 would be, right about there. If you looked at it at this, you'd say, well, we're warmer in the east, and this is the last of the real core La Nina cool pool. The official El Nino monitoring region, they call it the Nino 3.4 region, starts at 120 west, 5 degrees north and south of the equator, goes out to about 170, so a bit off the picture. So you can see cool water still, for the most part, filling the official El Nino monitoring region, but the Nino 1.2 region, like right around in here, getting warmer, certainly warmer than what it's been. Let's dig a little deeper. 7-day trend, paints the picture very clearly. Anything that's orange and red is getting warmer than normal, and all we care about is what's really on the equator. But you can see from Ecuador the whole way out to, in this case, 140. Actually, Hawaii is there. Temperatures are warming over that whole region. Now, they're not warm. They're just warmer compared to what they were 7 days ago, which was pretty darn cold. So this sort of hints at the demise of La Nina. Not enough to wipe it out yet, but this has been going on in fits and starts for weeks now. Again, suggesting we think we're past the peak of La Nina. See water temperatures especially rising here off of Peru too. So a pretty good expanse of coverage. And just a quick look again. Here's that, wouldn't call it a building warm pool, but a return to normal, or slightly above normal temperatures here on the equator in the far East Pacific. Here's the bulk of your La Nina that remains. This is not really, quote unquote, officially in the El Nino monitoring zone, but clearly if you have this mass of an area of cooler than normal waters, it definitely is going to affect the global upper and surface circulation pattern consistent with La Nina. Here's the temperature trend. The CDS Nino 1.2 index is there, right up there along Peru and Ecuador. Temperatures today still 0.562 degrees below normal, half a degree, 0.6 of a degree below normal. But you can sort of see, if you draw a line through this, an average line, you can see a trend towards warming. Now, this is not the official El Nino monitoring region. This is that area, though, where we saw the warming occurring. This is the official El Nino monitoring region, the Nino 3.4 region, but temperatures here warming as well, 0.861, so a little bit less than 3/4 of a degree below normal. The trend here, it's pretty much flat. This is not enough of a trend to say we're warming. We don't think we are. Still got maybe a month or two to go before any significant warming occurs, if it is to occur. But officially speaking, El Nino is, you go, well, that's only 3/4 of a degree or so. That's not very much. Well, El Nino is half a degree above. El Nino is half a degree above La Nina, half a degree below normal for 5 consecutive months. So you see, we've been clearly in a La Nina pattern here for the entirety of this graph since mid-October or whatever this is, 2 weeks or so. So you get the idea. We've been here a while. The atmosphere has changed. The jet stream has changed because of these colder than normal temperatures, and they're not much. But it speaks to how sensitive the atmosphere is to even relatively small changes in temperature in the oceans. The atmosphere changes with it, and likewise, the atmosphere then reinforces what goes on in the ocean. And then our final stop on the tour, what's the atmosphere think is going on? The Southern Oscillation Index, difference in pressure between Tahiti and Darwin. Darwin is Australia. We're considering that generally the Indian Ocean. Tahiti, of course, in the Pacific. When the index is negative, then that suggests lower pressure in the Pacific. When it's positive, it is considered higher pressure in the Pacific. Today, our value, 5.66. But you see, we were up 22, 20, long runs of 30s and 20s above normal. That speaks to the continued ongoing La Nina situation. This is kind of noisy. You see there are some negatives thrown in every now and then. The 30-day average, good for monitoring the MJO. Today, 16.80, that's positive. And it's been, well, you see, pretty much positive for a long time, suggesting a steady state inactive phase of the MJO. The 90-day average, definitely a lagging indicator, but I think we said when you hit 12, you're in La Nina. Well, definitely we are. 12.99, still going up, and this will probably continue to rise for another 30 days before it starts plateauing off or so, but this is a lagging indicator for sure. I mean, we know we've been in La Nina for months now, but this just confirms officially that the atmosphere fully thinks we're in La Nina. But we knew that too, just from looking at the jet stream models. Again, this is a lagging indicator, but it just, is the final nail in the coffin of we are in La Nina. And what it also means is that the ocean and the atmosphere are coupled. The ocean is cold. The atmosphere is responding in turn, meaning less high pressure in the Pacific on average, high pressure building over the Pacific. When you have colder than normal water over the equatorial Pacific, that chops out evaporation. Evaporation is what transports energy up into the atmosphere. When you don't have evaporation or less evaporation, less clouds, clearer skies, you get bulletproof high pressure, which in turn feeds trade winds, which in turn feeds more upwelling, and the two, the atmosphere and the ocean, start working together, and they just start churning out stronger than normal trades that goes for months and months and months, and that continues the upwelling, pushing all warm water off to the west like we saw in the previous charts. Then at some point, the whole house of cards collapses, and the pendulum swings in the other direction towards El Nino. We are anxiously awaiting that pendulum swing, but we don't have any illusion that we think it's going to happen any time in the immediate future. So here's a quick look, 30-day Southern Oscillation Index over time. Here was our big peak at 21 in, first week of January, something like that. We're starting to come down off that peak, but you can see the trend since, we'll say October of 2019, so that is a year plus ago, has been steadily upwards towards this building La Nina event. The downward spikes here are the active phase of the MJO. The upward spikes are the inactive phase. The way you get here is the inactive phases of the MJO are stronger and more numerous than the active phases. You see, you're trying to get these little bits of active phase. They just keep getting stomped out by the broader trend, the cycle of La Nina, and that's how we ended up here. But once you get up here, there's only one place to go, and that's down, and that's the direction we want to see. Now here's where things get really interesting and kind of strange at the same time. The official sea surface temperature forecast for the Nino 3.4 region. Here's where we are today, mid-January. Temperatures, 3/4 of a degree below normal. This is the forecast. Now, we had seen previous versions of this where the temperature was supposed to rise to maybe 1/3 of a degree, 1/4 of a degree below normal in July and then just hang there. This week, the model went haywire, suggests we're supposed to go right back down by October into some deep La Nina hole of minus 1.75, 1 3/4 degree below normal in October. That seems a bit of a head scratcher. Seems not possible. The other thing that's going on here is we're not there yet, but the spring unpredictability barrier starts in the late March, early April timeframe and goes into about the early June timeframe. All the models have a very hard time figuring out what's going to go past that barrier. Once you get into June, all of a sudden they get a much better handle, but we're approaching the transition phase when the atmosphere has to make up its mind. Am I going to keep going La Nina? Am I going to go neutral? Am I going to go El Nino? This model, it's good in some ways, but it appears to be really struggling at this minute. So we're not at this time taking this at all seriously, but it is something to sort of keep in your back pocket just to remember. Then here's the data from the IRI CPC. Here's all the different dynamic El Nino models. Here's all the different statistic models. Their results are all plotted out here. Let's see if I can see this. The dynamic average, the dynamic model average is the red line here, and it basically says it returned to neutral. The statistic model average says a return to normal, maybe 1/10 of a degree below that, and so that's April, May, June. So we're just looking at the first one, April, May, June, July, August, September. So as we get into, let's say, the June time frame, and that's the end of the spring unpredictability barrier, most of these models are saying, hey, we're going to be back to neutral. In fact, we can scroll down here. We're not going to get into all the details, but here's all the different models. Here's the dynamic models. Here's their numerical temperature readings for each of the 3-month periods. And then here's their average. You see return to basically neutral in, well, we'll say, what is this here? That is what? July, June. Then the statistic model, same deal. In fact, you look at the output from the two of these, start comparing them. They're almost the same. So the, where is the, just for laughs, where is the CFS model? Here's the one that we're looking at. Now, see, this is an last week's version. It didn't have that skyrocket drop down into oblivion of temperatures. It hadn't picked up on it yet. So we'll be watching. This only updates once a month. The other model that we look at, this one here, updates every day. So we follow it. It gives us maybe, and it is a pretty sensitive model. It gives us a little hint of what's coming. Sometimes a little bit erratic, but still, it's the earliest leading indicator on the hairy bleeding edge. So we like to follow it. So for right now, yes, swell is in the forecast for both the U.S. West Coast and Hawaii. U.S. West Coast, though, pretty much going to be inundated with piles of local wind swell, raw conditions. That's good, though. I mean, we need the rain. We need the snow. We don't believe we're going to get the 200 or 300 inches, whatever the models say, but still a very healthy dose of snowpack for the Sierra. That's good for our water getting into the summer if it materializes, but so far the models have been pretty stable. Atmospheric river event forecast for the Sierra. The avalanche danger will probably be off the charts. You do not want to go backcountry skiing. You do not want to, you get caught in a blizzard, get caught in an avalanche. It isn't worth it. Just sit, let it happen, let things stabilize, and then let's see what happens. But our guess is also that, like our surf season, where we got all our surf probably for the entire year, all mashed into a 3 or 4 week window, we suspect the snow season will be much the same. Who knows? We'll see. We're just guessing. But we probably are not going to have another run like what we just had later this year. It just, the dynamic, none of the models suggest it, and nothing's there that suggests that's going to happen. We suspect the snow thing's going to be the same thing. Why? Cleaner conditions, strong trades in control, but there will be surf there, but coming from a pretty good distance away. Long wait between sets. Beyond that, the El Nino, La Nina thing, hard to say. We're getting close to the spring unpredictability barrier. We're still about another month and a half out, something like that. But you can see already the models are starting to flip-flop around, not quite sure what's going to go on. So that's a big question mark for now. But the general thought is we're probably past the peak of La Nina. Can't believe we're going to do a double dip, 1 degree or below normal La Nina 2 years in a row. But who knows? Stranger things have happened. If that happens, that for sure rules out any sense that we're moving into the warm phase of the Pacific Decadal Oscillation. But that's a discussion for a different day, different time. All right, so if you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe. You get automatic notifications when we post the videos. If not, go to stormsurf.com. We post the video link at the top of every page of the site, pretty much right after we posted it, and you can follow along there. And comments, questions, please write them in the comments section. We'd appreciate it. The algorithms like it too. We want to be popular a little bit, but not too popular, and we appreciate your support. All right, that's it for this week. We'll do it again next week, same time, same channel. Stay safe.